And there's a robust amount of literature on scaling equipment, scaling the playing area, scaling those things that we just talked about in that step model, the space, the task, the equipment, the number of people to improve motor skill acquisition. Let's go to the next slide. You'll see here that this systematic review, what they basically found was that by manipulating these various constraints, by scaling the equipment or the playing area, you had all these profound beneficial results you can see in the left-hand side. Youth athletes, youngsters had a better functional fit with that environment, and therefore they had a much better experience. And not only that, they improved their skill acquisition and skill adaptation. And I know Rich has a couple comments on this.
Yeah, so Michael and I, over the course of this project, have discussed the importance of implicit learning back in chapter one, and so it's important to understand that properly scaling information goes hand in hand with this idea of implicit learning. We scale information so that we're able then to meet the learner where they're at, and then create tasks and be the architect of environments that are digestible for that learner at that given time in their learning period. And if this is done properly, then the task and the environment do the speaking for us, and there is a lot less need for us as a coach to provide a lot of that explicit instruction, which can be paralyzing to a young learner. So, an example of this would be using forms of errorless learning when we're guiding athletes during this process of learning a new task. So, for example, if I'm working with a young, rather inexperienced baseball pitcher, I may not want to start by having that pitcher try and throw strikes from a full game distance, because the chance for him to make errors is probably going to be pretty high. So we can use this errorless learning type approach, and a coach can maybe put them closer to the plate, thereby reducing the chance for large amounts of error. Now, I do want to make sure that I'm clear here. They are absolutely allowed to make errors. Learning is messy, and errors are important. However, early on in this learning period, the chance for them, if the chance for them to make errors is kept smaller, it can lead to more confidence, and it can lead to higher levels of engagement. So as they start to become a little bit more confident and more masterful at the task, then increases in distance and difficulty can kind of rely on their level of performance. So, when they can start to throw 7, 8, 9 strikes out of 10, 11, 12 pitches, we can start to move the distance back a little bit. Now, I do want to say this also isn't a linear process like we've talked about before. You don't have to complete step one before you can move on to step two. You don't want to bury them, but you can slide up and down this scale of difficulty, even in the learning process. The point being, though, is we just want to make sure that we don't inundate them with failure to start, because if you do, they'll become very, disinterested in that task. There's been a lot of research on more than just baseball, but there's been similar studies using this idea of errorless learning in tasks such as putting a golf ball or free kicks in soccer. And again, what they've concluded is that by minimizing errors early on, less explicit instruction is needed by the coach, which again increases opportunities for implicit learning. And just real quick before we move on, a couple of important reminders regarding information and equipment scaling. It's important to remember that we need to avoid completely removing critical information sources. So scaling information and scaling equipment cannot violate the contextual principles of the game. So this means that we need to, again, simplify information sources, not remove them, to cater to the learner's current abilities. So an example of removing, or violating, I should say, contextual principles would be the use of a tee in baseball. The ball in a baseball game, in the game, it travels. It's leaving from a pitcher's arm, and it moves to home plate. And so by setting a ball on a tee and taking the ball flight out of it, that would be an example of violating a contextual principle. So instead, you could do things like reduce the speed of the ball, reduce the distance that it's coming from, change add a different variety of trajectories that the ball may travel at, increase the ball size, increase the bat size, different types of ideas like that, where you're not completely removing the information. You're just, again, scaling it down to where that learner is at. And so, again, this idea, the properly scaling, then allows learners not only to maintain, but also allows them to be in a position where they can enhance the perception and action couplings that are required during performance of the actual full size competition.